Hi ladies, Mr. O'Sullivan. Today we're going to be looking at lesson 6-5, exponential growth word problems. Today's learning target is I can solve a word problem containing exponential growth by creating my own exponential function. So what we're going to be doing today is we're going to be learning how to write this equation to find out what happens in certain years. So we learned about linear functions, now we're going to be learning about exponential functions. So there are formulas for exponential growth and decay. Today we're only going to focus on growth. So you do not have to calculate each year by hand. If you have to calculate each year by hand, it's actually very challenging, it's pretty daunting, it's pretty excruciating. So the exponential growth formula is actually going to be, y equals a times 1 plus r to the t power. And what each part means is actually very specific. Your a stands for your initial amount, or how much you start with. Your r is your percentage as a decimal. And to get your decimal, you divide by 100. And then last but not least, t is time. And that time can be in days, months, years, hours, seconds, etc. So if we go to the right, we have these percentages, and we need to convert them to decimals to find our r value. So if I have 84%, if I want to calculate that and put that as a decimal, all I'm going to do is take my 84 and divide it by 100. So I just have to do 84 divided by 100, and I get 0.84. And that would be my final answer. For this next example, I have 6.2%. So I'm now going to do 6.2 divided by 100. And when I do 6.2 divided by 100, I get 0.062. And then when I do 0.5 divided by 100, I get 0.005. So that's what I would be putting in if I had to find my R value. Now let's find the growth percentage by hand. This actually is not that daunting. To find the growth percentage, first you have to figure out if it's growth or decay. Like I said before, everything we do today is going to be growth, everything we do tomorrow will be decay, and then when we get back from the break, we're going to do a mix and match. So to find your growth percentage, look at the number in the parentheses. If the number is bigger than 1, it's growth. If the number is smaller than 1, it's decay. Note, the number is not your percentage. You actually have to find it. It's a one-step equation. So if I look at this example, we want to find out the initial amount. We have to identify whether it's growth or decay, and then determine the percentage of rate of increase or decrease. It's very, very straightforward, I promise. If we look at this example, we know that our equations are written in the form y equals a times 1 plus r to the t, where a is our initial amount. So if I look, this is my initial amount right here. It's attached to my parentheses on the outside. So if I look, the number attached to my parentheses on the outside is a 350. So I can say that my initial amount is 350. Now, if I look at the number on the inside of my parentheses, or my 1.01, that's larger than 1, correct? Yeah, it's larger than 1. So this is an example of growth. Now, it says determine the percentage rate of increase or decrease. Well, since it's a growth, it's going to be a percent increase. So the first thing I do is I actually write down that 1.01. So I'm going to write down 1.01. And now what we do is we actually make this little one-step equation called 1 plus r is equal to 1.01. Now we need to get r by itself. This is a one-step equation. We are going to subtract 1 from both sides of our equation. So I get r equals 0.01. Here's the issue. That's my r value. I want the percentage. So instead of dividing by 100, we're going to multiply by 100. And when we do 0.01 times 100, we get 1%. So this is actually not a huge exponential function. It's not growing very quickly. Okay. Now let's look at our next example, number 2. I have y equals 9200 times 1.11 to the x power. The first thing I have to ask myself is my initial amount. What's my initial amount? Well, my initial amount is the number attached to my parentheses, so my initial amount is 9200. Now I have to ask myself if this is a growth or decay, so I go to the number on the inside of my parentheses, which is a 1.11, and that's bigger than 1, so this is a growth situation. Now we need to figure out what that percent is. So what we're going to do is we're going to rewrite that 1.11, and now we're going to set our equation equal to it. So we're going to do 1 plus r equals 1.1. 1. My apologies. So got to get r by itself. So I'm going to subtract 1 from both sides. Get r equals 0.11. Now I have my r value. I need to find the percentage, so I'm going to multiply by 100. And I get r equals 11%. Well, not r equals 11%. I get a percentage of 11%. And that's my final answer. So this is an 11% growth. So this is actually growing, but I mean, it's not fast, but it's growing much better than 1%. Number 3. I have y equals 27 times 1.51 to the x power. First thing I got to ask myself is my initial amount. Well, I look, my initial amount is 27. So that's how much I'm starting with. And it's the number attached to your parentheses. Now I have to ask myself, is it growth or decay? So I look at my parentheses. I got a 1.51, bigger than 1, it's growth. Part C, determine the percent rate of increase or decrease. I rewrite that number on the inside, so I'm going to write that 1.51. And now I do 1 plus r equals 1.51. Subtract 1 from both sides. Get r equals 0.51. Here's the issue. Still gives me the decimal. Got to find the percent. So I'm going to multiply by 100. And I get 51%. So this is actually growing very quickly. It's going to grow very, very, very quickly. This is the fastest growing function on our page right now. Okay. Now let's go on to some word problems where we actually have to do some solving. Application. The population of Winnemucca, Nevada, I think that's how you pronounce it, I'm not sure, can be modeled by p equals 6191 times 1.04 to the t power, where t is the number of years since 1990. This is very important to pay attention to because we're not starting at year 0, we're starting at 1990, which is our year 0. So part A says, what is the population in 1990? Well, if I look, that's when this function is starting. It's starting at the year 1990. So all it's asking you is what's your initial amount for the function. So if I look, my initial amount is going to be 6191 because this is year 0. So if I look at year 0, I'm going to basically just have 6,191 people. And that'd be your final answer. Now, part B says, by what percent did the population increase each year? So now I look at the number on the inside of my parentheses. So I have 1.04. Now I'm going to do the 1 plus r equals 1.04. Solve for r. Subtract 1 from both sides. Get r equals 0.04. Thing is, that gives me the decimal. I want the percent. So now I've got to multiply by 100. And that gives me 4%. So this is a 4% increase each year. Let's go on to part C. What was the population in 1995? Interesting question. Well, if I'm starting in 1990 and I'm going to 1995, how many years have taken place? Very good, 5 years. So what I'm going to do is I'm just going to plug in 5 to this equation. So I know that I'm just going to do, everywhere I see a t or an x, however you want to view it, I'm just going to plug in a 5. So I'm going to do P5 equals 6,191 times 1.04 to the 5 power. And you need to do this on Desmos. You cannot do this on your phone calculator. You need to download Calculate 84. There's a calculator app on the Android. Or your iPad, you need to use Desmos or one of those. You can't use the iPhone calculator, just a heads up. So when I type this into my calculator, I get a long number. I get 7532.298119. Here's the issue. We're talking about population, so we're talking about people. Is it possible for you to have a decimal of a person? No, it's either a full person or not a person. So what we would do is we would actually round this number down because it's 0.298119. So what I would get is my final answer is 7,532 people. So I'd only focus on this part of my answer. Okay. Now, D, during what year did the population hit 9,000? So I don't know what the year is, so I want to find out that time. So I'm basically setting my equation or my function equal to 9,000. So my equation would look like this, and I'm going to show you how to do it. I do 9,000, and I set it equal to 6191 times 1.04 to the t power. Here's the issue. We don't know how to solve that. You're in 9th grade. You don't know how to solve that. I'm not teaching you how to solve it because you don't learn how to solve this until the 11th grade. I'm going to let Miss Daniel show you. But here's how we solve it in Algebra 1. We go to our calculator. So I'm going to go to this app, and I highly recommend we download it. It's called Calculate 84. If you look at Calculate 84, I'm going to go to y equals, and I'm going to clear this. I'm going to go to y equals. I'm going to type in my function. I'm going to type in 6191. Got to make sure there's no decimal before it. Times 1.04. Close my parentheses. I'm going to hit this caret, and I'm going to raise it to the x power. Now, I'm just going to show you something. If I graph it, I don't see anything, so I'm going to hit second graph, and I want to look to see when it will hit 9,000. So if I look, I hit 6191, I hit 6438, 6696, 6964, 7275, still haven't hit 9,000. Let's go, let's go, let's go. Still haven't hit 9,000, but if I look at year 10, I hit 9,164. So I can say after 10 years, I will have hit 9,000 people. So 10 years. So during what year? It's going to take 10 years. So t is approximately 10. So the population will hit 9,000 after 10 years. If I look, we start in 1990. So what's 1990 plus 10? 2,000. That's your final answer. Okay. Let's go on to number 2. In 1980, about 2,180,000 U.S. workers worked at home. During the next 10 years, the number of workers working at home increased 5% per year. Write a model giving W and millions of workers working at home T years after 1980. So when we look at this example, the first thing we want to do is we want to rewrite our equation. So we're going to write y equals a times 1 plus r to the t. And if I look, I want to find out what my initial amount is. So my initial amount is 2,180,000. So I have y equals 2,180,000 times 1 plus. Now I need to find my r value. Well, my r value is my percentage. So my percentage is 5%. So I take that 5% and I divide by 100. What's 5 divided by 100? 0.05. So I get 1 plus 0.05 to the t power. And that's your final answer. There's an issue though. If you look, it says in terms of w. So I'm going to erase my y and put a w. Because you want variables in terms of w and t. Okay. Part B. How many million workers worked at home in 1986? Well, the question's asking. How many years has it been since 1980, basically? So if I look, it's only been 6 years, so I'm going to plug in 6. So plug in 6. So we go to our equation, which is W equals 2,180,000, 1, 2, 3, times 1 plus 0.05. And now I'm going to plug in 6 for t. I'm going to type that into my calculator. Beep, boop, beep, boop, beep, boop. And I get 2,921,408. Let me double check something. 1 second. Second mode. I get 2,921,408.497. But here's the issue. Can you have 0.497 of a person? Nope. So we just keep this as our final answer. So we actually just get rid of the 0.497. So this would be your final answer. Part C, estimate the year when there were about 3.22 million workers who worked at home. So basically we want to find out the year, so we don't know what t is. So t is a variable, sort of like solving for x. So we're going to rewrite our equation, but instead of putting w, we're actually going to put 3.22 million. We're going to set that equal to our equation of 2,180,000 times 1 plus 0.05 to the t power. So I'm going to go back to calculate 84, go to y equals, clear, And I'm going to type in my equation. So my 2,180,000, 1, 2, 3, times 1 plus 0.05 to the x power. And then I'm going to hit second graph. So I want to see when this is going to hit 3.22. I want to see when it hits 3.22. So I'm already at x equals 10, and I'm at 355, so that's past 322. So I'm going to go back, 338, boom, 322. And if I go over, I get x equals 8. So it's been 8 years. So t is equal to 8. So if I'm starting in 1980, I just do 1980 plus 8. So my final answer is going to be 1988. And that's it. So that is how you work with exponential growth word problems. You just have to really focus on making your equation and then figuring out, do I plug in or do I set equal and look at my table? If you have any questions, email myself or Miss Townsend. Have a great day, ladies.